Hello everyone, welcome to my channel. Now in this video I am going to discuss the topic of oblique projection or angular projection in case of projectile motion. Okay. Now see, when I say projectile, it means an object which is moving purely under the influence of gravitational force. Okay. Only force acting on it is the gravitational force. So suppose the most fundamental concept is, see, this is x-axis, this is y-axis. Okay. And the projectile, it can move like this, the vertical projection, okay, or horizontal projection is like it may be dropped and then it will fall like this, or angular projection is like if it is projected like this, it will go like this. Okay, so these are the various possibilities. Okay, other possibilities are also there, but these are the fundamental possibilities. Now see, it goes up and then it comes down. This is what happens. Okay, now it goes up, that means it is moving against gravity. When it comes down, that means it is moving towards gravity. Okay, so the gravitational force, it is going to act in along y-axis, along the vertical direction, along y-axis. Okay, now Newton Baba, the Newton, I say Newton, he gave the formula F equal to ma, that is the second law. Okay, now in this relation F is equal to ma, this force and acceleration, they are in the same direction. Okay, now gravitational force, it is acting in downward direction, so that means acceleration will also be in the downward direction. Okay, there is no force along the horizontal direction, so there is no acceleration along the horizontal direction. Okay, for normal cases. So acceleration, if this is x-axis, this is y-axis. Okay, so acceleration along x-axis, it is 0. Okay, this is another fundamental concept. Understand, now we have understood that acceleration along x-axis is 0, but what about acceleration along y-axis? When to take it to be plus g and when to take it to be minus g. Okay, see, there is often a confusion that with regard to sign of acceleration, like minus a, it means retardation, and plus a means acceleration. Okay, this is not a correct concept. Okay, when we will have retardation and when we will have acceleration. See, sign of acceleration doesn't say anything about whether it is accelerating or when the object is accelerating or object is decelerating. Okay, then how to find whether when we will have acceleration and when we will have retardation? So the main concept is, suppose if the velocity, if this is the direction of velocity and this is also the direction of acceleration. If velocity and acceleration are in the same direction, in that case the object is said to be undergoing acceleration. The object velocity will increase with time. Okay, accelerating object. So this is the case when there is acceleration. For acceleration, velocity and acceleration, they should be in same direction. Now in case you have velocity in upward direction and acceleration in downward direction, or velocity in downward direction and acceleration in upward direction. Okay, either this case or this case, when velocity and acceleration, they are in opposite direction, in that case the object is said to be undergoing retardation, that is velocity will be decreasing with time. Okay, now see, this appears to be some complex concept, velocity, acceleration, same direction, opposite direction, when to apply acceleration condition, when to apply retardation condition. Then to visualize that, just remember one example. See, if I throw this chalk in the upward direction, okay, it goes up and then it comes down. Now while going upward, see, velocity is in the upward direction, acceleration is the downward direction. Acceleration will be always in the downward direction, because for any object, me, you, this chalk, gravitational force is always acting in the downward direction. Okay, so whether it is going upward or whether it is going downward, force on this chalk, it is going to act in the downward direction. Okay, so if the force is acting in the downward direction, acceleration will be in the downward direction. So whether it is moving up during ascent or when it is coming down during descent, the acceleration is in the downward direction. Okay, that is clear. Now when it is going upward, velocity is in the upward direction. Okay, and acceleration is in downward direction. So we have seen that when velocity and acceleration, they are in opposite direction, then the object is said to be undergoing retardation, that is velocity is decreasing with time. So when we throw an object, the velocity will decrease with time. Velocity 5 meter per second, 4 meter per second, 3, 2, 1, 0. So at the highest point, the velocity becomes 0. So at the highest point, the velocity becomes 0, but it can't stay like that. Okay, because why? At the highest point also, it is acted upon by the gravitational force, so it is going to pull it down. So now it will start coming down. Now when it is coming downward, velocity and acceleration, they are in the same direction. When velocity and acceleration are in the same direction, the velocity will increase. The object is said to be undergoing acceleration, so it is coming down with increasing velocity. So 0, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5. So this is what happens. Okay, while ascending, the velocity decreases. While descending, the velocity increases. Okay, so this is with regard to the concept of acceleration, when to take positive sign, when to take negative sign, when it is acceleration, when it is undergoing retardation. Okay, now we will now suppose this is y-axis and this is x-axis. Okay, and the object is projected with velocity u and it goes like this. Okay, so this is the trajectory of the projectile. This is called the trajectory. Trajectory means the path traced by the projectile. Okay, the path traced by the projectile. So this is the trajectory. Okay, so trajectory is the curve along which the projectile moves. Okay, now as you can see at this particular point, this velocity vector, it is tangential to the trajectory. So this is another concept, that at any point on the trajectory, if you wish to find the direction of velocity, you draw a tangent at that point. The direction of tangent will give you the direction of velocity. Like for example, at this particular point, if you want to find the direction of velocity, you draw a tangent. Okay, so this tangent v, so this velocity vector, now it has become v, here it was u. So at this instant, the direction of velocity is like this. Okay, so this is how you calculate or you find the direction of velocity at any point on the trajectory. Okay, so this is one concept. Now suppose in this particular case we have, this is the trajectory, so theta is the angle of projection. Theta is the angle of projection. Okay, so this is u, this is theta, so this is u cos theta and this is u sin theta. Okay, so u cos theta is the component of velocity along x-axis along the horizontal direction. U sin theta is the component of velocity along the vertical direction. Okay, so what is the purpose of these two velocities? What are they going to do? Okay, now velocity of particle brings displacement. Because of velocity we get displacement, because of that the particle undergoes a change in position. So this u cos theta will move the projectile horizontally, and this u sin theta, it is going to move the projectile in the vertical direction. Okay, now see, from this point to highest point, suppose this is the highest point of the trajectory. Okay, so this is the highest point of the trajectory. Now see, this projectile is from this point to this point, it has come up. Okay, so who is bringing it in the upward direction? This u sin theta, but beyond this point it can't go any further. So that means the velocity component in the vertical direction, it becomes 0. Okay, because it is not moving any further. But this u cos theta, this is the horizontal component, so here also the horizontal component will remain u cos theta. Okay, why u cos theta? Because we have seen that acceleration along x-axis is 0. Okay, so if I take the velocity along x-axis as Vx is equal to ux plus ax into t. So at any time, if you substitute any value of t over here, this quantity will be 0. Now if this quantity is 0, that means Vx is equal to ux. So x component of velocity will remain constant throughout the trajectory. So if somebody asks you, in case of inclined projection or oblique projection or angular projection, when an object is projected at some angle to the horizontal, okay, in that case, what is the velocity at the highest point? So don't say the velocity at the highest point is 0. The velocity at the highest point will be u cos theta. Okay, and see, this velocity along vertical direction, at highest point it has become 0, but now it has to come down. So what happens? This velocity, see, this u sin theta is in the upward direction, here also it will be upward direction, but with a decrease in magnitude. At highest point it will become 0. Now beyond this, the direction of vertical component of velocity will be flipped, it will be in the downward direction, and now the projectile will come down and it will reach here. Here also the horizontal velocity will be u cos theta. Okay, horizontal component of velocity at any point along the trajectory, it is going to be u cos theta. Okay. If we see the motion along x-axis, so we have x is equal to uxt plus half ax t square. Okay, so this is x is the displacement along x-axis, ux is the velocity along x-axis, ax is the acceleration along x-axis. Time, I have written t without any subscript because time is independent of axis. It will be same both along x-axis as well as along y-axis. So since acceleration along x-axis is 0, so ax will be equal to 0. So we have x is equal to uxt, x is equal to ux into t. What is ux? Ux is u cos theta. So this is x is equal to u cos theta into t. Okay. Now this is for x-axis, but how about along y-axis? Y is equal to uy t plus half ay t square. Okay, so this is y is equal to u sin theta into t. This ay is minus g, so this is minus half gt square. Why I have taken this to be minus g? Because while it is going upward, velocity is in the upward direction and acceleration is in the downward direction, so there will be retardation, so therefore I am written minus g. Okay, so now if you substitute this from this, if I take t is equal to x by u cos theta, if I substitute this value of t is equal to x by u cos theta over here, this t and this t square, this t square and t I am going to replace, and then on replacement I get y is equal to x tan theta minus gx square divided by 2u square cos square theta. Okay, so what you can do, you can pause the video at this particular position and substitute this value over here and do check whether you are getting this equation. So I hope you have checked now. So we have this equation, y is equal to x tan theta minus gx square divided by 2u square cos square theta. Okay, so what does this equation represent? See, this equation y is equal to x tan theta minus gx square divided by 2u square, this equation is of the form y is equal to ax minus bx square, where a and b are constant. A is this tan theta, b I have replaced to be g by 2u square cos square theta. Okay, now this is of the form of a parabolic equation, and if we keep these constants and if you change the value of x, okay, you will get this curve. Okay, and this is the, we have already defined this curve to be as trajectory. So that means this equation represents the trajectory equation. Okay, equation of this curve, and since it is in parabolic form, we can say that trajectory of the projectile is parabolic. Okay, but that is one important concept. But what are the other beautiful things that you can observe from this equation? This is x equal to 0, y equal to 0. Okay, now if this distance, if I take this distance to be r, and we call it as horizontal range, okay, so that means along x-axis this distance is r, so obviously this point coordinate will be r comma 0. Okay, so this is x comma 0, this is r comma 0, this is the x coordinate and this is the y coordinate. Okay, so for both these values y coordinate is 0. Okay, and for that means for y equal to 0 you are getting two values of x, that is x equal to 0 and x equal to r. That is also we are observing from this equation, because here this is y order is 1, here x order is 2. So one value of y is related to two values of x, and one among them is x equal to 0. The other values of x is the range r. So let's see whether we are getting that equation over here. So I can write this equation as y is equal to x tan theta minus gx divided by 2u square cos square theta. I have taken x common. Okay. Now for y equal to 0, if I substitute y equal to 0, there are two possibilities. One possibility is this x is 0. Okay. So one possibility is this x is 0. The other possibility is this quantity is 0. If this quantity is 0, I can write gx by 2u square cos square theta is equal to tan theta. If this quantity is 0, that means this is equal to this. So from this I can write x is equal to 2u square cos square theta. Tan theta is sin theta by cos theta, so one cos theta terms gets cancelled. So this is cos theta sin theta by g. Okay. Now this is 2 cos theta sin theta, so that is equal to sin 2 theta. So we have x is equal to u square sin 2 theta by g. So this is the value of x. Now that value of x corresponds to r, that is the horizontal range. So this is the expression for horizontal range. Okay. So this is one implication of this quadratic equation. Okay. There is one more quadratic equation we have got, that is if y is equal to u sin theta into t minus half gt square. Okay. So what is the beauty of this equation? Now as we have seen in the previous case, here again left side order of y is 1, right side order of t is 2. So there are two values of t for same value of y. What does it mean? It means suppose we have two poles, these two poles of same height. Okay. And this projectile is crossing the two poles, just crossing the two poles without hitting the poles. It is crossing this pole at time t1, it is crossing this pole at time t2. So these t1 and t2 are 2 points along this trajectory. Okay. I can write this equation as half gt square minus u sin theta into t plus y is equal to 0. Okay. Now this is a quadratic equation, and the solution of this quadratic equation is t1 and t2, because t1 and t2 are the points on this curve. Now sum of the roots is equal to minus b by a for a quadratic equation. Sum of the roots is minus b by a. Minus b by a implies minus of minus u sin theta divided by g by 2. So t1 plus t2 is equal to twice u sin theta by g. Okay. So this is t1 plus t2 is equal to twice u sin theta by t. So t1 plus t2 is equal to twice u sin theta by g. We have also done the deduction for total time of flight, and that expression for total time of flight is also 2u sin theta by g. So what conclusion you can make? Sum of these two roots is equal to time of flight. That means the projectile will cross two poles which are at same height at time t1 and t2, and if you add those two times, you will get the total time of flight. Like suppose it is crossing the first pole at time t1 is equal to 2 seconds, and it is crossing the second pole at time t2 is equal to 4 seconds. That means the total time of flight will be t1 plus t2, 2 seconds plus 4 seconds, that is equal to 6 seconds. Okay. So this is another important observation. There are two times at which a projectile will have same vertical displacement, and if you add those two times, you will get the total time of flight. So these are some of the additional concepts which are quite important with regard to your JEE main preparation also. So I hope this video, in addition to class 11 students, this video will also be useful for class 12 students who are preparing for JEE main 2020. So my best wishes to all of you. Hope this video benefits you. Good luck.